Students, this is El-Refaei, math teacher with both AS and A2 level. Today we're going to talk about solving modulus inequalities. But before I start this class, you have to watch topic 1.1, solving modulus equations. I'm going to use the same method I used to solve modulus equations, but put extra one or two steps. We said to solve modulus equation, we have three ways. Way number one, sketching. Way number two, change sign. And way three, squaring method. I'm going to use one of the three ways, and I'm going to add extra step. In this way, I'm going to solve modulus inequality. Modulus 2x plus 4 less than 2. For way one, sketching, I'm going to divide it into two equations. Y equals 2x plus 4. 2x plus 4 equals 0. So x equals negative 2. xy, negative 2, negative 3, 0. Negative 2 gives me 0. Negative 3 as a modulus. 2 by negative 3, negative 6, plus 4, negative 2, it will be 2. And 0 will give me 4. Y equals 2. As you see, I have two solutions. I'm going to focus on two solutions where the two graphs intersect. They intersect when x equals negative 3 and x equals negative 1. Let's go back to the inequality. I'm talking about when the line is above or greater than the modulus. Where's the line be above or greater than the modulus? This is the line, the modulus. So when the line is greater than the modulus, happens when x is more than negative 3, less than negative 1. Let's use way 2, change in sign. I'm going to consider that this is not an equality, this is an equation. And I'm going to solve it as an equation. 2x plus 4 equals 2, and 2x plus 4 equals negative 2. So x equals negative 4, negative 2, x equals negative 1, negative 6 divided by 2, so x equals negative 3. I'm going to draw another line. I have to choose a value less than negative 3, for example, negative 4. A value between negative 3 and negative 1, for example, negative 2. And a value greater than negative 1, which is 0. I'm going to substitute these three values in this inequality to discover out which one of them will give me correct inequality. Let's start. 2 by negative 4 plus 4 less than 2. Negative 8 plus 4, negative 4 modulus 4 less than 2. So this will give me incorrect inequality. Let's use negative 2. 2 by negative 2 plus 4 less than 2. 0 less than 2. So this will give me a correct inequality. 2 by 0 plus 4 less than 2. 4 less than 2. This is incorrect inequality. To have a correct inequality, x will be more than negative 3, less than negative 1. I hope this is a clear, student. Example B, 3x minus 5 modulus less than or equal x minus 1. Let's use method 3, the squaring method. X minus 5 squared equals x minus 1 squared. Going to use the same steps I used to solve modulus equations. 9 x squared minus 30x plus 25 equals x squared minus 2x plus 1. 8x squared minus 28x plus 24 equals 0. X equals, I'm going to use general formula, negative 20, positive 28 plus minus negative 28 squared minus 4 by 8 by 24 divided by 8 times 2, and I'm going to get 2x values. X will be 2, x will be 1.5. I'm solving an inequality, not equation. I'm going to draw a number line. I'm going to pick up a value less than 1.5, for example 1, a value between 1.5 and 2, let's say 1.6, a value greater than 2, for example 3. I'm going to substitute these three values in this inequality to find out where I can get a correct inequality. Let's start. 3 by 1 minus 5 modulus. Does it give me more than or equal 1 minus 1? 3 by 1 minus 5 modulus 2 more than or equal to 0. So this is correct inequality. Let's move to 1.6. 3 by 1.6 minus 5 modulus more than or equal 1.6 minus 1. It gives me 0.2 more than or equal 0.6. This is incorrect inequality. Let's move to the third number. 3 by 3 minus 5 modulus more than or equal 3 minus 1. 9 minus 5 equals 4, more than or equal 2. So this is a correct inequality. Putting to that, the answer will be when x is less than or equal 1.5, x is more than or equal 2. Another example. I'm going to use a change in sign, for example. X minus 4 equals 2 minus x. I'm going to consider it as an equation to find where the two modulus functions intersect. 2x equals 6, so x equals 3. X minus 4, negative 2 minus x. X minus 4 equals negative 2 plus x. So I have no solution. Drawing the number 9, I have one intersection point where x equals 3. So I'm going to pick up a value less than 3, which is 0, a value more than 3, which is 4. I'm going to substitute 0 minus 4 modulus less than or equal 2 minus 0 modulus. So 4 less than or equal 2, incorrect. Second value, 4 minus 4 modulus less than or equal 2 minus 4 modulus, 0 less than or equal to 2. So this is correct. Those are the values of x which give me a correct inequality when x is more than or equal to 3. I'm going to use the squaring method. 2x minus 3, all of them squared, equals 2 minus 5x, all of them squared. 2x minus 6, all of them squared, equals 2 minus 5x, all of them squared. 4x squared minus 24x plus 36 equals 4 minus 20x plus 25 x squared. I'm going to move the whole terms to the right side. 21x squared plus 4x minus 32 equals 0. I'm going to use the general formula. X equals negative 4 plus minus 4 squared minus 4 by 21 by negative 32 over 21 by 2. I'm going to get two x values. X equals 8 over 7. X equals negative 4 over 3. I'm going to draw the number line. We get to 4 over 3, 8 over 7. I have to choose a value less than negative 4 over 3. For example, negative 2. A value between negative 4 over 3 and 8 over 7, 0. A value greater than 8 over 7, 2. Let's check. 2 modulus negative 2 minus 3 more than or equal to minus 5 by negative 2. This is will be 10 more than or equal 12. Incorrect. Second value 2, 0 minus 3 modulus this more than or equal to minus 5 by 0. 6 more than or equal to, this is correct. Third value 2, 2 minus 3 modulus more than or equal to minus 5 by 2. 2 more than or equal negative 8, and this is also correct. So the solutions for this inequality, when x is more than or equal negative 4 over 3. Going to use the squaring method. 2, 3x minus 1 all of it squared equals x plus 1 all of it squared. 6x minus 2 squared equals x plus 1 squared. 36x squared minus 24x plus 4 equals x squared plus 2x plus 1. 35x squared minus 28x plus 3 equals 0. So this is 36. I'm going to use the general formula. 26 plus minus negative 26 squared minus 4 by 35 by 3 over 35 by 2. I'm going to get two answers. X equals 1 over 7. X equals 3 over 5. I'm going to draw the number line. 1 over 7, 3 over 5. I'm going to choose a number less than 1 over 7, 0. Between 1 over 7 and 3 over 5, 0.5. More than 3 over 5, 1. Check. 2, 3 by 0, minus 1, less than 0 plus 1. 2 less than 1, incorrect. 2, 3 by 0.5 minus 1 less than 0.5 plus 1. 5 by 0.5, 1.5 minus 1, 0.5 by 2, give me 1 less than 1.5. So this is correct inequality. 2, 3 by 1 minus 1 less than 1 plus 1, 4 less than 2, incorrect. So the correct answer, when x more than 1 over 7, I did not try the equality sign because I don't have equality value. X more than 1 over 7 less than 3 over 5. So the extra step is drawing the number line, pick up a values, and substitute. I hope today class is clear. See you in another class. Don't forget to solve the exercise. See you then.